This video discusses the similarities and the differences between the for the 5 steps in hypothesis testing for the 4 different hypothesis tests that are going to be tested in test 3. So let's look at this table. All of our hypothesis tests have these 5 steps. The first step is where we are identifying the claim, creating null hypotheses and the alternate hypotheses, and I include in that step 1 identifying what the significance level alpha is. This is the same in all 4 of these tests: test of proportion, test of mean, test of standard deviation, test of difference between means. How we determine what the relationship or what the null and alternate hypotheses are, the relationships in those hypotheses, is exactly the same in all 4 of the hypothesis tests. The only difference then in the first step is, what is the parameter? For a test of proportion, the parameter is p. For a test of the mean, the parameter is mu. For a test of standard deviation, the parameter is sigma. For a test of difference between means, the parameter is mu1 minus mu2. All 4 of the hypothesis tests have a step 2 in which the test statistic is calculated. We would look in the statement of the problem to get the appropriate sample information, and we would look in H0 to get the value of the parameter, the assumed value of the parameter, to put in to the formula when we see the parameter in the formula. And the formulas are different though. For a test of proportion, it's Z, and we see that P is the parameter that is used in Z. Test of the mean, it's T, and we see that mu is the parameter that is in the formula for a test of mean. And for test of standard deviation, the test statistic is called chi-squared, and we see that the sample standard deviation is in there, as well as the population standard deviation, sigma. And in test of difference between means, we don't see the parameter in there, mu1 minus mu2. That's because in the formula, and it's a T, by the way, in that formula, the parameter mu1 minus mu2, the assumed value is always 0. So where that parameter ends up, it's 0. So I just left it out. So this is all we need to put into the test of difference between means is the sample information. And the test, step 3 is where we determine if the test statistic that we found in step 2 was unlikely or not unlikely. There's some slight differences in how we do things in each of the different hypothesis tests. For instance, in the test of proportion, we can either use table A2 to find critical values, or we can use the inverse norm function on the calculator, which we would get to by doing second vars and hitting number 3. And it requires that we put in a less than probability to find the area to the left. I mean, we would put in the area to the left of the critical value, and that would give us the critical value that has that area to the left. For a test of mean, we would use table A3. And for a test of standard deviation, we would use table A4. And for a test of difference between means, we're going to just use the 2-SAMP t-test. And remember, all hypothesis tests on the calculator give us 2 things. They give us the p-value and the test statistic. So we could use the 2-samp t-test to get the test statistic and get the p-value at the same time. And we would ignore the critical value entirely for test of difference between means. And the p-value approach is slightly different in each of these tests. We can use table A2 to find p-values, or we can use the normal CDF function to find p-values for a test of proportion. We would get to the normal CDF function by doing second vars number 2. And the normal CDF function requires that we have a lower bound on the area to the farther away from the mean than the test statistic value, and then an upper bound. Now, what goes in for the lower bound and upper bound depends upon which side of the test, or which side of the mean the test statistic falls. If it's on the left, the lower bound is negative infinity, the upper bound is the test statistic. If it's on the right, the lower bound is the test statistic, and the upper bound is a large positive number. We use a similar function for finding the p-value for a test of the mean, and it's called the t-CDF function. And it is also in second vars, but it is number 6. It would actually be number 5 for a TI-83 plus, and 6 for a TI-84 plus, TI-84 plus. And again, the same thing applies here for lower and upper bounds. Left bound for a left side test statistic is negative infinity, or a large negative number. The upper bound would be the test statistic. And for the right, the upper bound or lower bound would be the test statistic, and the upper bound would be a large positive number. So pretty much the same as what we did for the test of proportion, for the normal CDF. For the test of standard deviation, slightly different. It again is a CDF function. It's again in the same location, second vars, but it is number 8 for a TI-84 plus, or number 7 for a TI-83 plus. And if the test statistic is, and by the way, the chi-squared function starts at 0 and goes to positive infinity, so it has no negative values. The mean of the chi-squared is the degrees of freedom, sample size minus 1. So everything is relative to that mean rather than relative to 0, which was the mean for the proportion and mean test. So for a test statistic that falls below that degrees of freedom value, the p-value, you will find the area to the left of the test statistic, and so the lower bound for that is going to be 0, and the upper bound is going to be the test statistic. On the right side, since it goes to infinity, the lower bound is the test statistic, and the upper bound is a large positive number. And the p-value method for the difference between two means is just going to be is going to come from the 2-samp t-test. And then there are tests of hypothesis tests for the proportion and for the mean and for difference between means. We've already talked about the one for difference between two means, giving us the test statistic and the p-value. For proportion, it's the one prop z test, and you get to that by hitting stat, right arrow to test, right arrow to test, and hitting the number 5, one prop z test. And then you would put in the assumed value for the parameter p by looking at H0. And you would put in the information from the sample, and then you would put in or identify what the relationship was in the alternate hypothesis. And then you have a choice of either hitting calculate, in which case the data is presented to you, or you could hit press or select draw, and it's going to give you a p-value sketch, show you the areas underneath the curve, show you the test statistic, and show you the p-value. For the t-test, or test of mean, it's the t-test, which is number 2. Again, it's stat, right arrow to test, number 2. And again, you're going to put in the assumed value for the mean that comes from H0. And you're going to put in the sample information, sample mean, sample standard deviation, and sample size. And you're going to identify the relationship in the alternate hypothesis. And again, you've got your choice of calculate or draw, which gives you the p-value sketch and the t-value, test statistic, and the p-value. There is no test on the calculator for the test of standard deviation. For the two-sample t-test, I've already talked about that, but you can get to that by doing stat, right arrow to test again, but it is number 4. And again, the assumed value is 0, so you don't have to put that in. It's always going to be 0 for this test. You just have to put in the mean, sample standard deviation, and sample size for each of the 2 samples. And you're going to select the correct alternate hypothesis relationship. And again, you can calculate or draw on that one as well. In the things that are exactly the same are the last 2 steps. Decision step, step 4, is you're going to make your decision using critical value by rejecting H0 if the test statistic is farther from the mean than the critical value on that side. And for the p-value, you're going to compare the p-value to alpha. If the p-value is less than or equal to alpha, you will reject. This is going to be true for all 4 hypothesis tests. Statement of conclusion, you're going to use the same thing here. You're going to use the flowchart from the formulas and tables handout, and you're going to just answer the 2 questions. Did the original claim include the condition of equality, yes or no? And then for each one of those situations, you either rejected or failed to reject, and that's going to give you 4 possible sets of words to use in your statement of conclusion. And you're going to use those same words no matter which test of the which hypothesis test you're doing. And remember, in each one of those, whichever words you get to by answering those 2 questions, you have to repeat the original claim at the end of those words. And so that tells us the similarities and the differences between or among the 4 hypothesis tests that are going to be tested on test 3.